There is a sealed concrete basin in the southern Urals that used to be a lake. From a satellite, it looks like an empty field with some gravel on it. You could fly over it in a plane and never notice. But buried under that gravel are 440 quadrillion becquerels of radioactive waste. It is the most contaminated place on Earth. It was filled in by hand with rocks over 40 years. And the city built next to it does not appear on any map, was erased from the Soviet census, and still cannot be entered without permission from the Russian secret police. This is the story of what the Soviet Union buried under the Ural Mountains, and why, 70 years later, they are still burying it. In 1945, the Soviet Union watched the United States flatten Hiroshima and Nagasaki, and it understood immediately that it was behind. Stalin wanted a bomb. He wanted it fast. The job of getting it for him fell to a man named Lavrenti Beria. Beria was the head of the Soviet secret police. He was, by most accounts, the most feared man in the country after Stalin himself. He had a reputation for getting results, and the methods he used to get them were not the kind of methods that left witnesses. Beria selected a remote spot in the southern Urals, far from Western eyes, between the towns of Kyshtym and Kasly. The location had two things going for it. It was about 1,400 kilometers east of Moscow, deep enough into the country that no foreign aircraft could realistically reach it. And it had lakes. A lot of lakes. Reactors need water, vast quantities of water, to carry away the heat they generate. The chain of natural lakes around the construction site looked, to the engineers, like a ready-made cooling system. Construction began in 1945 and was finished in 1948. 40,000 prisoners from the Gulag system, plus prisoners of war from the just-ended war in Europe, did the building. They worked in conditions that nobody bothered to document. Most of them did not know what they were building. Most of them were not allowed to leave when the work was done. What they built was a plutonium factory. The first reactor, called A1, went online in June 1948. It was a uranium graphite reactor, water-cooled, optimized for one thing: producing weapons-grade plutonium as fast as possible. Safety considerations were secondary. Waste management was, for all practical purposes, an afterthought. By August 1949, the first batch of weapons-grade plutonium had been produced. That same plutonium was loaded into the Soviet Union's first atomic bomb, designated RDS-1, which detonated in Kazakhstan on August 29, 1949. From the moment Beria broke ground in the Urals to the moment the Soviet Union became a nuclear power, 4 years had passed. 4 years is not enough time to do this safely. Everyone involved knew that. Nobody cared. The reactors at Mayak used a method called open-cycle cooling. Here is what that means. Water was pumped through the reactor core, where it absorbed heat and inevitably picked up radioactive contamination from the fuel and the surrounding metal structures. In a properly designed reactor, that water is contained, cooled, and recirculated so the contamination stays inside the loop. At Mayak, in the rush to get the bomb finished, the engineers skipped that step. The water came out of the reactor radioactive, and they simply released it. Released where? At first, into a nearby lake called Kyshtym. The lake was the largest natural body of water adjacent to the plant, and on paper, it had enough volume to handle the cooling demand. In practice, it became contaminated almost immediately. So the engineers switched to a smaller, closer lake called Karachay. We will come back to Karachay. And then, when even that became too small to handle the volume, they did something simpler. They poured the high-level waste straight into the river. The river is called the Techa. 41 villages sat along its banks. The total population was around 124,000 people. For most of them, the Techa was the only source of drinking water. They watered their cattle in it. They washed their clothes in it. Their children swam in it. They caught fish from it and ate them. They cut hay from the floodplain meadows and fed it to their cows, and they drank the milk and ate the meat, Between 1949 and 1956, the Mayak plant released roughly 100 petabecquerels of radioactive waste into that river. The numbers translate into something like 2.8 million curies of activity. About 95% of that was discharged in a single concentrated burst between March 1950 and November 1951. The waste was a mixture of fission products: strontium-90, cesium-137, ruthenium isotopes, zirconium, niobium, various rare earth elements. Some of these decays quickly. Strontium-90 and cesium-137 do not. Their half-lives are about 30 years each, which means the contamination released in 1950 was still half there in 1980, and is still about a quarter there today. In 1951, Soviet scientists finally got around to measuring the riverbank in the village of Metlino, 4 miles downstream from the plant. Background radiation in a normal place is about 0.21 roentgens per year. The riverbank in Metlino was reading 5 roentgens per hour. That is not a small difference. 5 roentgens per hour is the kind of dose rate you would expect to find inside a hot zone of a recently shut down reactor, not on the bank of a river where children played. The villagers were not told. The measurements were classified. So now we have the setup: a secret plant, a river full of fission products, a population drinking it, feeding it to their livestock, and a government that has decided, as a matter of policy, that none of this is happening. Now let's talk about the tank. By 1953, the engineers at Mayak had started building underground storage for high-level liquid waste because even they had begun to realize that pouring it into a river was not a long-term plan. The storage facility was a row of stainless steel tanks, 14 in total, sitting in a concrete canyon 8 meters underground. The canyon was lined with concrete walls more than a meter thick. The lid of the canyon was concrete too, weighing 160 tons. Each tank held tens of thousands of liters of dissolved nuclear waste. The waste was the byproduct of the plutonium extraction process the Soviets used, which was different from the process the Americans used at Hanford. The Soviet process is called sodium uranyl acetate. It involves dissolving the irradiated reactor fuel in nitric acid, altering the oxidation state of the plutonium, and then adding acetic acid and a base to precipitate the uranium and plutonium out as a solid acetate salt. What is left over after you take the plutonium out is a hot, acidic broth full of fission products and unreacted process chemicals: ammonium nitrate, acetates, various organic compounds. The Americans never used this process. They used a different method called Purex. The reason this matters is going to become clear in a minute. Each tank generated its own heat, because radioactive decay is not a quiet process. The decay heat from the waste was substantial. Without active cooling, the temperature inside the tank would rise. So each tank was surrounded by a cooling system, a loop of water flowing around it to carry the heat away. There were also instruments inside the tank, in theory, to monitor the temperature and the chemical composition of the contents. The instruments were inadequate. The cooling system on one of the tanks failed. Nobody fixed it. This is the part of the story that does not quite fit into any rational framework. The cooling system failed, and instead of repairing it, the technicians left it for more than a year. The ambient radiation in the canyon was high enough that nobody wanted to go down there. The dosimeters were primitive. The protective equipment was primitive. The bureaucratic incentive to report the problem and have it fixed was negative because reporting problems at a secret weapons facility was the kind of thing that ended careers and sometimes lives. So they stopped going down there. They reasoned that the waste inside the tank would stay liquid even without active cooling. They were wrong. What was actually happening was this: the waste inside the tank was heating up. The water in the slurry was evaporating. As the water evaporated, the chemical mixture concentrated. The remaining sludge became drier and drier. Ammonium nitrate, which had been dissolved in solution, began to crystallize. The acetates, which were organic compounds, were now sitting in close contact with the crystallizing oxidizer. The tank was becoming, slowly, a homemade bomb. Ammonium nitrate is the same chemical that destroyed half of Beirut in 2020. It is a fertilizer. It is also an explosive. When you heat it sufficiently in a sealed container with organic compounds for company, it does what explosives do. On September 29, 1957, on a Sunday, the tank reached approximately 350 degrees Celsius, and it detonated. The blast was equivalent to between 70 and 100 tons of TNT. It blew the concrete lid off the canyon. The lid weighed 160 tons. It landed 80 feet away. A brick wall in a building 200 meters from the canyon was destroyed by the shock wave. A column of radioactive smoke and dust rose a kilometer into the sky. Witnesses described the dust glowing orange-red as it settled on the buildings and the people. Residents of nearby villages, looking at the night sky in the days that followed, described seeing strange bluish-violet colors. The local newspapers speculated that they were polar lights, drifting unusually far south. Roughly 20 million curies of radioactivity were released. About 90% of it settled within a few kilometers of the tank, contaminating the plant grounds and the immediate surroundings. About 2 million curies of the lighter, finer material was carried up into the column and pushed northeast by the wind. It traveled 350 kilometers before it settled. The plume left a contaminated strip of land roughly 300 kilometers long and 30 to 50 kilometers wide. This area was given a bureaucratic name, the East Urals radioactive trace. 270,000 people lived inside it. Now, let's talk about what happened next, because the explosion is not the story. The cover-up is the story. For the first hours after the blast, nobody in the city of Ozyorsk noticed anything was wrong. Cars and buses drove through the contamination on their way back from the plant, and the contamination came with them on the tires. Workers walked through the fallout and brought it home on their shoes and their clothes. The contamination spread along the main road, named after Lenin, and along Shkolnaya Street, where the plant management lived. By the time the dosimetrists noticed the background radiation spiking in the city itself, the city was already dirty. They set up wash stations at the gates. They forbade people to enter Ozyorsk in cars and buses from the industrial side. Everyone, regardless of rank, had to get off the bus, walk through the checkpoint, and have their shoes washed. The city had been built deliberately upwind from the plant, on the assumption that the prevailing winds would carry any contamination away from the residential areas. On September 29, the wind was wrong. The Soviet response was to evacuate. Eventually, a week later, on October 6, an operation began to remove around 10,000 people from the most contaminated villages. The villagers were not told why. They were not told what had happened. They were just told to leave. Some were evacuated within 7 days, others waited 250 days, some waited 670. The contaminated soil was excavated and stockpiled in fenced enclosures. The Russians had a phrase for these enclosures. They called them graveyards of the earth. The pattern of evacuation tells you what the priorities were. The villages that were emptied first were the ones closest to the plant, where the contamination was high enough that people would have started getting visibly sick within weeks. The villages further out, where the contamination would only kill statistically, over decades, through cancers that nobody could trace back to a single afternoon in 1957, were left in place. 2 villages on the edge of the official evacuation zone, called Tatarskaya Karabolka and Musakayevo, were never evacuated at all. The official explanation was that their contamination level was just below the threshold for resettlement under Soviet law. The actual contamination, measured by independent investigators after the fall of the USSR, was substantially higher than the official figure. Plutonium, 2, 3, 9, and 240 inches soil samples taken near Tatarskaya Karabolka by Greenpeace in 2002 were measured at about 10 times the level you would expect to find in unaffected territory. The Soviet Union officially denied that the accident had occurred. They would deny it for the next 30 years. This is where the story gets stranger, because the cover-up worked. Vague reports of a nuclear accident in Russia appeared in the Western press as early as 1958. A short item in a Vienna newspaper in March 1959 carried the first specific details. The CIA, flying U-2 spy planes over the Urals, knew about the disaster by 1960. They had photographs of the damage. They knew approximately how big the contaminated zone was. They had a rough sense of what it meant. They said nothing. Why? Because the United States was at the same time building its own nuclear industry, including a plutonium production facility at Hanford in Washington state, which had its own waste problems and its own contaminated rivers. The Hanford site released large quantities of radioactive iodine into the air during the same years that Mayak was dumping waste into the Techa. The American public did not know about that either. According to declassified files later obtained under the Freedom of Information Act, the CIA kept the Mayak accident secret to prevent Americans from worrying about American reactors. The consumer advocate Ralph Nader put it bluntly in the 1970s. The information had not been released, he argued, because the agency did not want to highlight a nuclear accident in the USSR that might cause concern among Americans living near nuclear facilities at home. So for most of the Cold War, the worst nuclear disaster in history sat hidden in plain sight, protected by the silent agreement of two nuclear superpowers who had each, in their own way, decided that telling the truth was politically inconvenient. It took until 1976 for the story to break, and it broke from an unexpected direction. A Soviet biologist named Joris Medvedev, then living in exile in Britain, published an article in the journal New Scientist describing the disaster. He had heard about it from contacts inside the Soviet scientific community, and he had pieced the rest together from his own knowledge of how the Soviet nuclear industry operated. Western nuclear authorities mocked him. Some suggested he was confused, or that the contamination he was describing was actually fallout from a distant weapons test. The American National Laboratories quietly briefed reporters that Medvedev's claims were probably exaggerated. So Medvedev did something clever. He went back through published Soviet scientific literature on radiation ecology, looking for studies that Soviet authors had conducted on contaminated land in the Urals. The Soviet scientists had been allowed to publish their work because the contamination itself was secret, but the studies were generic enough, framed as research on radiation effects in general ecosystems, that they had passed the censors. Medvedev read the studies. He cross-referenced the locations, the isotopes, the dates. He found papers describing experiments on hundreds of square miles of contaminated terrain, with isotope ratios and contamination densities that could not have come from a weapons test. He proved the disaster had happened by reading the work of the people who were quietly studying its aftermath. A second émigré, Professor Lev Tumerman, formerly the head of the biophysics laboratory at the Institute of Molecular Biology in Moscow, then came forward and corroborated Medvedev's account. Tumerman described having driven through the East Urals radioactive trace between Sverdlovsk and Chelyabinsk, on a road where signs warned drivers not to stop, only to keep moving. The Soviet government finally admitted the accident in 1989, more than 3 decades after it occurred, in the dying years of the regime that had buried it. Now, let's come back to the tank, and to what was happening to the people who had lived along the Techa River the whole time. Because here is the thing about the Mayak story that almost nobody outside the region understands. The 1957 explosion was the worst single event, but it was not the worst exposure. The worst exposure was the one that had been happening continuously since 1949. The river. The villages along the river, the cows grazing on the floodplain, the milk, the fish, the drinking water. The Russian government eventually built a registry of the affected populations. The people who lived along the Techa during the years of maximum discharge between 1949 and 1956 became what is now called the Techa River cohort. There are about 30,000 of them. They have been studied for decades by Russian researchers and, after the fall of the USSR, by international collaborators. The data is grim. Excess cancers, excess leukemia, cases of chronic radiation syndrome, a condition almost unknown in the West, in which long-term low-dose exposure produces a constellation of symptoms: impaired blood cell production, neurological problems, immune dysfunction, low blood pressure, tremors. Around 66 villagers in the most contaminated zones were diagnosed with chronic radiation syndrome, and these cases provided the bulk of what the world now knows about the condition. About 49 to 55 excess cancer deaths along the river have been confirmed by epidemiological analysis. These are the conservative numbers. The real numbers are almost certainly higher. The reason they are uncertain is that radiation-induced cancer is clinically indistinguishable from any other cancer, and the only way to count it is statistically, across large populations, over long periods of time. Soviet doctors were also instructed, in the early years, not to diagnose patients with anything specifically radiation-related. They were told to write down blood problems or vegetative syndromes instead. So the medical record, where it survives at all, is a record of what the Soviet state allowed to be written down, not of what the doctors actually saw. In the village of Musliumovo, 50 kilometers downstream from the plant, the population was never evacuated. The reason was not officially given. The unofficial explanation was that Musliumovo had become a research site. The villagers, exposed continuously to low-dose radiation for decades, were a unique scientific cohort, the only one in the world. Studying them would yield data on the effects of chronic low-dose exposure that could not be obtained any other way. According to a sociological survey conducted in Musliumovo in 2002, 62% of the residents believed they were the subjects of a medical experiment. 74% did not trust the specialists from the Mayak plant. Greenpeace surveyed Musliumovo in 2002 and found cancer rates 2.6 times the Russian national average. A cytogenetics study of 3 families, 20 people including 5 children, found chromosomal abnormalities at 25 times the normal rate. 88 residents of the village officially carried a diagnosis of chronic radiation sickness. The Russian government eventually offered to relocate the residents. They moved them to a new district called Novo Musliumovo, which was built next to the village cemetery, on land where the well water was still 2 to 3 times above the intervention level for radioactivity. The relocation moved only the riverside half of the village. The rest of Musliumovo was left where it was. This is the part of the story where you start to understand why the burial is never finished. The contamination keeps moving. It moves with the wind. It moves with the water. It moves with the cows that graze on the floodplain, and the fish that swim in the river, and the dust that the children kick up walking to school. The Techa cuts through 800 kilometers of the Russian landscape on its way to the Iset, which flows into the Tobol, which flows into the Irtish, which flows into the Ob, which flows into the Kara Sea, which is part of the Arctic Ocean. Every gram of strontium, 90, dumped into the Techa in 1950 has been moving in that direction ever since. Which brings us to the lake. Lake Karachay was the dumping ground. After the engineers stopped pouring waste directly into the river, they started pouring it into Karachay. The lake was small, about half a square kilometer at its largest, and shallow, only a few meters deep. It had no surface outflow. The reasoning, such as it was, went like this. The lake has no outlet, so anything we put into it will stay in it. The reasoning was wrong, but it was the kind of wrong that takes decades to become obvious. For nearly 40 years, Mayak used Karachay as an open-air container for high-level liquid waste. By the late 1960s, the lake contained an estimated 120 million curies of radioactivity, concentrated in a body of water that you could walk across in 15 minutes if walking across it would not have killed you. For comparison, the entire Chernobyl disaster released somewhere between 50 and 100 million curies, spread across thousands of square miles. Karachay had more radioactivity than Chernobyl, in a smaller area than a typical city park. In 1967, the region had a drought. The lake began to dry up. The exposed sediment caught the wind. Radioactive dust blew across an area of around 1,800 square kilometers, contaminating settlements that had already been contaminated by the 1957 explosion. Around 400,000 people were irradiated a second time. The same families, in some cases, who had already been irradiated by the 1957 cloud and the years of river dumping. Tatarskaya Karabolka, the village that should have been evacuated in 1957 and was not, sat squarely in the path of the 1967 dust. 3 nuclear disasters, 1 population. After the 1967 dust event, the engineers began a different kind of project. They started filling the lake with rocks, with concrete blocks, with dirt. Between 1978 and 1986, they dumped almost 10,000 hollow concrete blocks into Karachay to keep the sediment from moving. The work continued through the 1990s and into the 2000s. The lake shrank from half a square kilometer in 1951 to a fraction of that. In November 2015, the final layer was put down. The lake was sealed. In December 2016, the conservation work was officially declared complete. The most contaminated body of water on Earth had been buried, by hand, with rocks. A delegation that visited Karachay in 1990 took dosimeter readings at the spot where the effluent entered the water. The readings were 600 Roentgens per hour. Standing at that spot for 1 hour would deliver a lethal dose. The delegation did not linger. The World Watch Institute later described Karachay as the most polluted spot on Earth, and the description has not been seriously challenged. But here is the thing about sealing a lake by dumping rocks into it. The sediment at the bottom of Karachay is not inert. It contains roughly 4.4 exabecquerels of high-level liquid waste. That is a number so large that it does not really mean anything in human terms. So let me put it differently. The seal at Karachay has to outlast the radioactivity underneath it. The principal isotopes are cesium-137 and strontium-90, with half-lives of about 30 years each. After 300 years, roughly 10 half-lives, the radioactivity drops to about 1,000th of its original level. After 600 years, to 1,000,000th, the seal has to hold for at least 300 years, probably more. The seal is made of rocks, soil, and concrete blocks in a region that experiences seasonal freeze-thaw cycles, occasional droughts, and the slow geological processes that affect any piece of ground over centuries. Nobody knows whether the seal will hold. Russian engineers admit that no country, including Russia, has experience maintaining a site like this for the timescales involved. Now let's come back to the tank, because we have not finished with what happened in 1957. The tank that exploded was not the only tank that had been mismanaged. The cooling system at Mayak had been understaffed and underfunded for years. The instrumentation was inadequate. The reporting culture was hostile to anyone who flagged a problem. After the explosion, an internal investigation found that the cooling failure was not an isolated incident. It was the kind of failure that the system was designed to produce. The director of the plant, a man named Demyanovich, took official blame for the accident and was relieved of his duties. The industry minister, E.P. Slavsky, signed a memo blaming the head of the radiochemical plant and the chief engineer of this plant, who committed a gross violation of the technological regulations for the operation of storage of radioactive solutions. Both men were named, both were dismissed, Both were eventually rehabilitated and went on to other jobs in the Soviet nuclear industry. The tank itself, or what was left of it, was not removed. The canyon was decontaminated as best as could be managed. The surviving tanks were inspected, and the facility went back into operation. Plutonium production resumed within weeks. The plant did not stop. The plant has not stopped since. By 1990, weapons-grade plutonium production at Mayak was officially terminated. By 2025, the plant was still running 2 reactors, generating tritium for the maintenance of Russia's existing nuclear arsenal and producing plutonium-238 for radioisotope thermoelectric generators, which are used in spacecraft. NASA has bought plutonium-238 from Mayak. The plant is also still reprocessing spent nuclear fuel, including fuel from foreign reactors. Bulgaria, Hungary, the Czech Republic, Slovakia, Finland, Ukraine, and the former East Germany have all shipped their nuclear waste to Mayak for processing under various agreements. Until 1993, the radioactive byproducts of that reprocessing remained permanently in Russia. After 1993, a Russian presidential decree required the high-level waste to be returned to the country of origin. But the decree was modified in 2001 and again in 2007 to allow indefinite storage in Russia. The total volume of foreign spent fuel reprocessed at Mayak by 2001 was over 1,500 tons. The total volume of low-level and intermediate-level liquid waste produced by that reprocessing was over 3 million cubic meters. Most of it went into the Techa cascade of reservoirs, the 4 artificial lakes built between 1951 and 1964 to contain the waste that no longer went straight into the river. The Techa cascade is still operating. Reservoir 11, the last lake in the chain, is held back by a dam. The dam leaks. Independent estimates put the leakage at 5 to 6 million cubic meters of contaminated water per year, seeping into the Techa River through the dam itself and through bypass channels that were built to carry rainwater around the reservoirs. The strontium 90 concentration in the Techa near Musliumovo in 2002 was almost 3 times the official Russian intervention level. In 2004, it was 6 times. The villagers were still drinking from local wells, but the wells in some cases sat in the floodplain, and the floodplain was still contaminated. In 2017, something happened that brought Mayak briefly back into the international news. A cloud of ruthenium-106 was detected over Europe. The detection was made by routine monitoring stations across the continent, which had been set up after Chernobyl to catch exactly this kind of event. The cloud appeared in late September and persisted into October. The concentrations were not high enough to be a public health threat in Europe itself, but they were high enough to be obviously anthropogenic, and they were the largest release of artificial radioactivity into European airspace since Chernobyl. The French Institute of Radio Protection and Nuclear Security tried to track down the source. By process of elimination, looking at wind patterns and the timing of the release, they narrowed the origin to the Volga and southern Ural region of Russia. The release had occurred between September 25 and 28, and it had lasted less than 24 hours. The isotope signature was wrong for a reactor accident. Ruthenium-106 is a fission product, but if it had come from a reactor, it would have been accompanied by other fission products, and it was not. The ruthenium had been separated from everything else. That meant it had come from the late stages of nuclear fuel reprocessing, after the fission products had been chemically isolated from each other. The most likely explanation, according to the French investigators, was that Mayak had attempted to manufacture a capsule of cerium-144 for a research project at a particle physics laboratory in Italy, and the manufacturing process had gone wrong, and the ruthenium had escaped instead of the cerium being captured. Russia denied it. Rosatom, the Russian state nuclear corporation, denied that any accidental release had occurred at Mayak. The Russian government denied that any accidental release had occurred anywhere. Meanwhile, in the village of Argayash, 16 kilometers south of Mayak, Russian authorities themselves confirmed extremely high readings of radioactive pollution in the air during exactly the period the French had identified. This is the rhythm of the place. Something happens. Russia denies it. The evidence accumulates. Russia denies it some more. Eventually, decades later, the records are declassified, and the people who were exposed find out what they were exposed to, and by then, most of them are dead. There is one more piece of the Mayak story worth mentioning, because it illustrates the long reach of a place like this. In November 2006, a former Russian intelligence officer named Alexander Litvinenko was poisoned in London. He died over the course of 3 weeks, slowly, from acute radiation syndrome. The substance used to poison him was polonium-210, a rare alpha-emitting isotope that does not occur naturally in any meaningful quantity. It has to be manufactured, in a reactor, by neutron bombardment of bismuth. Mayak is one of the few facilities in the world that produces it. According to British investigators and subsequent public reporting, the polonium that killed Litvinenko had been produced at Mayak, the same plant that had poisoned the Techa villagers in the 1950s, that had exploded in 1957, that had sealed Karachay under a layer of rocks, that had released ruthenium over Europe in 2017, was also the source of the substance used to assassinate a critic of the Russian government in a London hotel. The lighthouse, when you look at it from a distance, has a long beam. Now, let's talk about what we still don't know. We don't know the true death toll along the Techa River. The official epidemiological estimate, around 50 excess cancer deaths from the river contamination, almost certainly understates the reality, because it only counts the most rigorously documented cohort, and because Soviet medical records from the 1950s were unreliable by design. We don't know how many cases of chronic radiation syndrome were misdiagnosed as something else. We don't know how many children born to exposed parents in the 1960s and 1970s carried genetic damage that has since manifested as cancers or birth defects in their own children. The cytogenetic studies in Muslumovo suggest the answer is more than the official figures admit, but how much more is a question the Russian government has never been interested in answering precisely. We don't know how much radioactive material is currently moving through the groundwater under Karachay. Independent surveys have detected gamma-emitting isotopes in nearby rivers, suggesting the seal is not as complete as the official statements imply. A plume of contaminated groundwater under the lake was reported in the early 1990s to be spreading at 80 to 100 meters per year. Whether it is still spreading, and how fast, is not publicly known. We don't know whether some of that contamination is making its way north, through the Ob River system, toward the Arctic Ocean. The Norwegians have been concerned about this for decades. They have funded studies. The studies have not been definitive. We don't know what is currently in the deep storage tanks at the plant. The original tanks from the 1950s have all been replaced or decommissioned, but the high-level waste that was in them has gone somewhere, and the somewhere is not entirely public. According to inventory estimates from the early 1990s, around 30 exabecquerels of solid and liquid waste had accumulated at the Mayak site. That number has only grown since. We don't know whether the cloud that drifted over Europe in 2017 was the only cloud. There may have been others, smaller, that did not get caught by the monitoring stations. We don't know what is happening this year, this month, this week, inside the buildings at Mayak. The plant is still classified. Foreigners are not allowed near it. Russian citizens who do not live in Ozyorsk are not allowed near it. Filming is forbidden. The exclusion zone around the plant covers 250 square kilometers and is patrolled. We don't know whether the seal on Lake Karachay will hold. 300 years is a long time for a layer of rocks. 500 years is longer. The radioactive sediment underneath the seal does not care how long. It will sit there, in the dark, slowly decaying, for as long as the chemistry takes. The seal has to last that long. Russian engineers have said publicly that no one in any country has experience maintaining a site like this for the timescales involved. Somewhere under the southern Urals, in a sealed concrete basin that used to be a lake, 440 quadrillion becquerels of radioactive material are sitting in the dark. The reactors above them are still running. The river beside them is still flowing. The villagers downstream are still drinking, still farming, still raising children on land that was never quite cleaned and was never quite told the truth about what happened to it. A digital clock in a town square in a village 20 minutes outside Ozyorsk switches between the local time and the current radiation level in the air. The radiation reading is, according to people who live there, never accurate. The lighthouse is still on.